Hi, my name is Luigi Penalosa and my teammate is Nikita Diaz. We're presenting the cryptography library in Python. Cryptography is a way of protecting a message from sender to receiver by obscuring the message. Encryption is converting plain text into ciphertext, which cannot be read unless decrypted. So decryption is converting the unrecognizable ciphertext into plain text. A cipher or algorithm, also known as a mathematical method, is needed to encrypt and decrypt. The two parties using the cipher also need to know a secret key or keys. A key is merely a long stream of bits, ones and zeros. The key or keys must be kept secret. There are two types of ciphers. Substitution ciphers, which substitutes one letter for another, and transposition ciphers, which do not change letters or bits, but changes the order. We will give examples of these types of cipher later.
Thank you, Luigi. So in this picture, we see a ciphertext example wherein the plain text is converted using to a ciphertext using a cryptographic algorithm, and it has a key which helps in its encryption. So if you can see to the right that there is a letter which states like some readable strings, but to the right of it, the corresponding cipher text message is something that is unreadable and cannot be decrypted without the key. So to give another example, we the rotation cipher here we use a rod negative 2. It's an algorithm that moves two spaces in reverse, hence the term negative 2. So as we can see in this example, if we look at the letter E, if it moves two spaces, it will go to the letter B. So E will be replaced by B, and that's how it's being done. And if there was like a rotation cipher just 2, then that would mean that it would go to the letter H if it moves if it jumps 2 letters forward. Moving on, let's look at hashing. So a hash function is basically a function that transforms all of your text messages into some sort of string that is encrypted using some sort of values and keys, and the result or the output of this hash function is basically the hash values, or it's also called as hash codes, digests, or simply hashes. So as you can see, if we input a string called fox, and if into the hash function, we get a digest with all sort of hash codes that are not at all recognized and unreadable. So this is what a hash function does. And for this installation, what we require is a package called Cryptography, and this provides cryptographic recipes and primitives. And it's supported by Python 2.7, Python 3.4 onwards, and PyPy 5.3 onwards. And to install it, it just requires a simple command on command line called pip install cryptography, and we are good to go. And these are sources that we used to.
As already stated by Nikita, we can install the cryptography package on terminal for Mac or command line for Windows by using pip install. Here's some code for encryption and decryption with a Fernet symmetric key. Symmetric means that both sender and receiver will use the same key for encryption and decryption. The plain text that we're encoding using the Fernet key is hello world. The B behind it turns strings into bytes. As you can see by the output of the ciphertext, we get a bunch of gibberish. To be able to read the original message, we pass the Fernet key again, and we can see that the original text is indeed hello world.
Moving on to the next algorithm, we'll be talking about Caesar cipher algorithm, which was basically the algorithm like the rod -2 that I explained in the presentation. So over here we create a function called encrypt, which has two parameters like a string or the input text and the shift or the rotations by which you want your alphabets to be shifted. And in the function, we have a cipher, which is a string, and we use a for loop which checks for every character in the string. If the character is a space, we add it to the cipher. Else, if it's an uppercase letter, we use the following expression. So in this Caesar cipher, we basically use the ASCII table that which as shown over here, wherein letters have an ASCII value. So A corresponds to 65, and for like capital letter A, and for lowercase a, it corresponds to 97. So moving back to the code, we use the character function, and the character function represents a string of the ASCII integer. So characters CHR 65 will give a result of A, and the ORD function ORDA will yields the number 65. So if we choose a character A, and if we suppose select a shift of 2, then it's supposed to give us the result C. So A shifted by 2 gives us C, and that's what it does. And we use the number 65 because it's checking whether it's an uppercase letter, and if it's a lowercase we use 97 and the return cipher. So and then we have the string input function. So just to give you an example, I'll run the code. So suppose if we have a string, say abduction, and it's going to ask us a shift number, say 2, then the original string is going to be abduction, and the decrypted one using the Caesar cipher algorithm will give like a random number C, D, F, W, where A corresponds to C, B corresponds to D based on the shift of 2. And moving on to the hashing algorithm. So here we have used an import hash lib, which is basically used to import the libraries used for hashing. And we create a variable called crypt, and we use hashlib.md5. MD5 is basically an algorithm, another encryption algorithm, and we use the string hello. If you notice, we have put a letter B in front of the string that basically converts the string into bytes, because that's how these algorithms in encryption work. And if we print the hex digest of this letter crypt, it's going to give us a hexadecimal format of the hello string as mentioned over here. And if you want to print the digest size, we use script.digest underscore size, and gives us the number 16. Just to inform you all again that digest is the output of the hashing function, and Luigi will explain the rest.
Hashes are good, but they can be easily reverse engineered. We can convert every word in dictionary to MD5 and then compare the hash given by the word hello. Also, if we copy the hash output and paste it into an online decryptor, such as md5decrypt.net, we can find the answer easily. This concludes our presentation. Thank you.